Hello team, welcome to this free YouTube series on the Agentic AI engineering. In this series, you will learn about the multiple topics on the Agentic AI. And those topics are the part of a complete Agentic AI course which is available on the Udemy. So if you really like this video, you really like the way how we are explaining the Agentic AI, then definitely you can go with the complete Agentic AI engineering course. And there you will learn about the complete agentic AI development from the scratch. You will learn how to build a real world autonomous AI agent, and it will be a complete step by step roadmap. The discounted link is already available in the video description. You can click it and you can enroll if you really like the way how we are explaining and you really like this content. Now let's move with this topic. And in the previous lecture, or maybe up to the previous lecture, we have seen that how we can create the custom tooling and how we can use that custom tooling within the LangChain. We have already seen that how we can trace the execution, the complete execution with the help of the LangGraph. But there is a problem. The problem is about the memory. So today we will see that why we need the memory and what is the checkpointing in the conversation. So let me show you an example. This is the chat or maybe the conversation which we have seen in the previous lecture. So let's do one thing. Let's execute the complete notebook. So over here you are getting an icon, play all or run all. Let's click this. What it will do, it will execute the complete notebook, the complete Jupyter notebook, right? And once the complete execution will be done, you see you are getting the blank chat because the new session is being invoked. Although we know very well that the LangGraph maintain the state. LangGraph maintain the state and it is using the reducer. But let's see how these things work in a practical. So let's say, hey, how are you? It is saying I'm just a computer program, so I don't have any feeling, but I'm here ready to help you. How can I assist you? So let's do some conversation and make this chat interactive. Thanks. My name is Anshul. What's your name? And it is saying I'm just called assistant. How can I assist you today, Anshul? So you see, from this particular conversation, it is able to understand my name, and whenever it is replying, it know my name, right? It know my name. Now let's give it a one more chance. Hey, what is my name? I'm asking this computer program, then what is my name? Then it tell you that I don't know your name. Can you please tell me? So you see, this is a one conversation history for you, right? You open this prompt, your chatbot, and you are doing a chat with a live assistant. That could be anything. Right now, this is a dummy program, but in a practical, that could be anything. You are telling the chat assistants about your details, about your queries, but it is not maintaining the things. It is not maintaining the memory. You see over here within this particular conversation, you mentioned, thanks, my name is Anshul. What's your name? It is saying, I'm just a called assistant. How can I assist you today, Anshul? It means as a part of this conversation, it got to know my name. But in the next chat, whenever I'm asking, hey, what's my name? It don't know anything. Why all these things are happening? Why all these things are happening? It is happening because of the state management. It is happening because of the state management. So whenever you created the Gradio interface, you see in each chat, what I'm doing, I'm using a graph invoke. I'm using a graph invoke. It means as a part of my chat, I'm submitting the history and I'm submitting the user input. In each conversation, I'm invoking the graph. You can again test it. Let me re-execute it. And before the re-execution, let's do one thing. Let's put a print statement. Result messages, result messages. Let's hit enter. Right? Nothing has happened. Let's put hi. And you see something is being printed over here. It is saying human message, content hi, additional arguments nothing, response metadata, then a ID is being generated, and the AI message. Hello, how can I assist you? This is the AI message, which is what I got the reply. Then we are getting the similar additional argument, the response metadata, and token completion, and the other things. Right? There is a lot of things. My name is Anshul. Hit enter. You see over here you are getting, hi, my name is Anshul. Additional argument is nothing. Then you are getting the transaction ID. And then you are getting the response. Hello Anshul, how can I assist you today? Over here. And then if you will go further, maybe more further, maybe more further, go more further, and go in the last, right? You see, nothing is mentioned about the previous conversation as a part of this history. Similarly, you are asking again, okay, what is my name? This message is being processed. This message is being processed and it say, I don't actually know your name. If you tell me, I can remember it for our conversation, right? It is asking to tell you your name, although you have already provided your name. And this is the next message. Okay, what's your name? Correct? State is being printed, and every time the state is being printed, I am getting something new. Output token details, output token details, output token details. It means what is happening over here. Every time you are submitting a chat message, graph.invoke is being called, and it is referring the user content. Now let's do one thing. Instead of printing the result over here, right? Let's do one thing. Let's open your chatbot and print this state, right? I will call it again, and I will call the Gradio interface again. Now I will again say hello. You will get the reply, and over here you are getting the messages. That human message is hello, additional argument is this, and ID is this. My name is Anshul. Then you are getting my name is Anshul. This is the part of the state, and over here you are getting the other data. What is my name? Now you are getting that human message state. So within the messages, within the list, it is maintaining the state, but it is not remembering your information. And how is that possible? And why every time I'm getting a new state over here? Why it is not referring the older one? Because you are not using the checkpointing. You are not using the checkpointing. You are not using the memory as of now, right? That's the reason. So if I will ask you today, why do you need memory? Why do you need memory in your AI agents or in the LangGraph? So now you have the answer that at a first look, LangGraph already maintains a state using the reducer and the state object, but it doesn't refer the older conversation. And what is the reason? The reason is a super step. Earlier, while I was explaining the super step, I told you that super step is a one full execution cycle of the graph. Super step is a one full execution cycle of a graph. Within a super step, the reducer keeps the state updated. It means if you have the multiple execution, the multiple nodes within a single conversation, then super step will keep the reducer state updated. But between the multiple super steps, between the multiple calls to graph.invoke, the state is lost. In that case, you need to save it. So LangGraph is already maintaining the state using the reducer and the state object, but that is just for the one super step. It means just for one invoke. It means if you have the multiple nodes as a part of a single super step, right, then the state will be maintained in that execution for a one super step. But between the multiple invocation, the state will not be maintained. You need to save it explicitly. The same example we are looking at here. While I am using a chat, I am using the graph.invoke. In each invoke, a super step will be created, right? And over here, whatever the state you are printing, that is a single execution, a single super step. So if you have the multiple node execution, then state will be maintained. Otherwise, the state will not be maintained. Let me show you. Just ask, hello, me the meaning of gold and tell me a joke and give me the price in USA. Let's suppose you are asking this. Hit enter. It will execute your query. Correct? Let's wait. Now you see the multiple messages being printed over here. Now over here you are getting your output. Gold is a heavy yellow element metal of grade value with atomic number 79 and symbol AU. Current price of the gold in the USA. As of the latest information, the current gold spot price is approximately 3,586.26 per ounce. And here, the joke about the gold. So it is again creating a joke about the gold. You are not asking joke on a gold. You are just asking, give me the meaning of the gold and tell me a joke. As a part of your query, if you remember, we created the custom tools. Three tools will be called dictionary, joke, and the search, web search. And this is the combination of all three tools are being called, and now you are getting the final output. You can trace the same thing on the langsmith. Open the default, and this is the latest execution. You see over here, one is called dictionary, second one is called the joke maker, and third is called the search, web search. All three tools are being called. You see over here the complete execution, right? These three tools called, right? Each tool has submitted the output to the OpenAI, and then finally you got the output. And the same thing will reflect in the state itself. You see from here it has started working. Hello, give me the meaning of the gold and this. What you are getting further? Over here you are getting the nothing. But in the next you are getting a AI message, the content. Correct? And then you are getting something about this. You see the complete state is being printed over here. Right? So you see within a one super step, this is a one super step, the one invocation. As soon as you will submit one chat box, this is a one invocation. In the one invocation, it has called the multiple tools and it has the reference from the previous one. So it is maintaining the state. It is maintaining the state. The reducer know that what is the conversation about, what is the output from the previous tool, and about what the user is asking. But as soon as you will send the another message, what was the price yesterday, then it will lost. It will don't know that what you are talking about, right? It will don't know what you are talking about. It is completely lost. So between the multiple super steps, it is not maintaining the state, and there you need the checkpointing, right? So what is the purpose of the checkpointing? What checkpointing is solving? Checkpointing solve that it will persist the state between the super steps, between the conversations, between the user turns, and even across the server restart. So right now, practically, you got to know that what is the super step and what is the purpose of the checkpointing. Correct? In the lang graph, each call graph.invoke is a one super step. I told you multiple times that each call graph.invoke is a one super step. So whatever the nodes, whatever the tools are going to execute as a part of the one invocation, that will be maintained within a single state. But as soon as the super step is done, if you are not using a memory, you are not using a checkpointing, then the next conversation don't know what you're talking about. So without the checkpointing, after each super step, the graph forget everything. With the checkpointing, the AI remember across the turns, sessions, and the failures. So you see how important and how useful it is, right? This is not just about the memory. Memory concepts is again breaked into the multiple fundamental units. The single execution super step, the multi execution or multi super steps, the multiple invocations, right? This is really impressing in the lang graph. So let's do one thing. Let's implement the solution. How we will maintain the memory. So I will go to the Visual Studio Code and I will add a markdown over here. And what we are going to mention, it is basically time to add the memory. So we are going to add the memory. And this is a lesson for you. A super step can be considered a single iterations over the graph node. Node that run in parallel are part of the same super step, while node that run sequentially belongs to the separate super step. And state is not shared between the multiple super step until unless you are using the checkpointing. So very first what we will do, we'll create a memory store. And how we will create a memory store? You need to execute a couple of import statement. So we are using langgraph checkpoint dot memory saver. And then you need to create the object of your memory saver like this. Once you will create the object of your memory saver, then again you need to create a graph builder, right? You are supplying the state which is being declared above, correct? After this, what you need to do, you need to basically create the LLM model, correct? So we created the LLM model over here. So we will execute those steps again. Initialize the LLM model. Over here again, we are going with the GPT-4o mini. After the LLM model initialization, what we will do, we will initialize with the tools. Now, after creating the memory store, what we need to do? Let's go to the previous implementation and copy the complete code. I'm going to copy this code from here, from the step 1 to the last step, correct? And I will put it over here. So what we are doing basically, let's make the change in the same code, correct? So very first, we are creating the LLM model. There is no change. We will create the LLM model. Second, we are creating a binding of the tools. So let it be, we are still creating the binding of the tools. Third, what we are creating a object of the graph, right? Or we are initializing the state graph. Let's create the graph builder and we are passing the state. Now, while we are creating a chatbot, we need to make some changes. What are those changes? Now, next what we are doing, we are creating a chatbot. This is the node execution. So there is no change. We are adding a node chatbot, no change. We are adding the tools, no change. We are adding the graph builder. We are adding the edges, no change. Then where is the change? What is the change we are going to make? The change will be in the compilation. While you are compiling your graph builder, you need to supply the checkpointing. You need to supply a checkpointing like this. Check pointer equals to memory. What memory? The memory object you created over here. The memory object you created over here. And after this, what we did, we basically displayed the graph. So let's do it. Even let's execute it. Let's execute the current code which you done. To identify there is any error, no compilation error. There is no compilation error. Okay, okay, let's do one thing. Let's execute the complete notebook from the very first. So you see over here, we don't have any message history. That's why the state is being cleared, right? Now let's do one thing. Let's visualize the graph. I will execute it. And you see, there is no change in the visualization. Again, we have the same start chatbot. And from the chatbot, we have the tools and the end. The memory is not in place. But over here, we have added the check pointer. And along with the check pointer, we have defined that what is the memory object you need to use. Is there any kind of change, any other change we need to make? Now let's do one thing. Like the earlier, let's create a Gradio interface. So I will copy this. And after initializing with the memory, I will create a fresh Gradio interface. So I will again copy the same code, whatever I have done earlier. So this was the code we was using. Let's copy it again and put it here. But there will be a slight change in the Gradio interface. While we are using the memory, we need to tell my chat box that you need to use this memory, correct? And how we are going to explain my chatbot to use the memory. So we will create a configuration. We'll create a configuration. And that configuration will be like this. Config, configurable, thread ID. And this is the Gradio specific configurable, right? This is not the LangChain specific configuration. So by defining this configuration, what we are, let me scroll down. By default, I executed it. Let me remove it. Clear cell output. So by defining this configuration, what we are trying to achieve. So basically by defining this configuration, right, this particular statement, we are trying to achieve that each conversation or user session is tracked with the thread ID. The thread ID we are defining over here. And if something we are defining over here, it means we need to use that particular thing as well. So let's use it. You just need to define one change over here. You need to pass config equals to config. That's it. That's the only change. Correct. That's the only change. Now let's execute this. Now you see you have invoked your chatbot, right? Let's start typing something. Hello. You will get the response. Hello, how can I assist you? My name is John. It is saying, nice to meet you, John. How can I help you? I'm a computer engineer. You are getting a message. That's great, John. Computer engineering is fantastic field. You're working on this specific project right now, or is there any something particular you would like to discuss? Now you see the clear difference. This is the one conversation where you told your name to the AI model and you are getting the response over here. And this is a separate conversation. We are just telling I'm a computer engineer, but the AI model know your name. how this AI model know your name from the previous conversation, right? It is being maintained by the memory. The change you defined over here, check pointer. The change you defined over here in the memory that is being reflected in your chat. You can ask, what is my name? Maybe you will receive your name. And how it is know your name? Because it is maintaining the complete state from the previous, and that is same being printed over here. As a part of the first history, as a part of the first conversation, you said hello. It is saying hello. Again, you mentioned my name is John. So you say the second line is here. Content hello. AI message is this. Now if you will scroll in the right side, right? Just go more, go more, go more, go more. And over here you see it is saying my name is John. So not just your current conversation, it is already maintaining your previous conversation. Now let's do one thing. Let's change this thread ID to 2 and again start it. This is your new chatbot and you said hello. It said hello. My name is Alice. Hit enter. It will tell you, nice to meet you, Alice. How can I help you? Then you say, tell me a joke. So it will process your request and it will give you a joke. And over here, you are getting the response. Basically, it is not able to execute the tool, but you are getting something over here. Now you say, do you know my name? And it is saying, yes, your name is Alice. Very fine. Now let's do one thing. Let's change this thread ID to 1 and again execute it. The chatbot is opened fresh and you ask the same thing. Do you know my name? And it said, yes, your name is John. It said, yes, you know your name is John. Is that possible earlier? You change the thread ID to 2 again. Invoke your graph again. The new chatbot will be opened. Ask the same thing. Do you know my name? And you will get your name is Alice. How these things are becoming possible? Because it is maintaining the checkpointing. It is maintaining the state, the complete state. Correct? Although as of now, the storage is in memory, but it is maintaining the state. If you will change the thread ID to 3, execute it again, and you will ask the same question. Do you know my name? Now it will be blank. No, I don't know your name because it don't know anything about the conversation with this ID. So you see what is the benefit of the checkpointing. You see how you can bake or use the inbuilt memory in your LangChain. You know very well that what is the concept of the invoke, what is the concept of the superstate, what is the concepts of the checkpointing, how checkpointing is basically help you that this is being maintained by the threads, the complete state will be maintained within the in memory, right? You know very well. And this is the same model how the chat GPT work. You know, every LLM model as of now you are using on a web console, they have the complete conversation history. That is something. The stateful AI agent. The AI agent with a memory. As of now, we are using the in-memory system, but in the upcoming lecture, we will create some kind of database kind of setup. I will try to use the SQLite or maybe some other database to save the AI agent memory, and we will create a complete stateful AI agent for our system. So now you can look at a practical example. Let's suppose this thread ID is associated with the user ID or the user number, and you are saving all the configuration and you are saving all the conversation in history. Now it doesn't matter that user may come back after the 3 months or 3 years or 30 years. If data is there, then your system will be able to recall the complete conversation with that particular user. It will be able to hold all the information about that user. It will be able to hold all the query about that user. And that is fantastic, right? You are basically building the stateful AI agent which have the memory power itself. I hope this lecture or this video helped you to understand this topic. If you really don't want to miss the next lessons, then please subscribe. And if you really want to learn the complete Agentic AI, the 22 to 25 long Agentic AI course, where you will learn about the multiple frameworks in the Agentic AI, you will learn how you can build the real world AI agent or real world autonomous agent, the complete Udemy course link is right below in the description of this video. You can go to the link, you can enroll the course and enjoy the seamless learning on the agentic AI engineering. Build your own agent and be a productive engineer. Thank you. See you next time.